In the world of computer graphics, we often need to manipulate objects to create realistic and visually appealing scenes. These manipulations are achieved through transformations, which are mathematical operations that alter the position, size, and orientation of objects within a graphical space. Imagine moving a chess piece on a board, resizing a window on your computer, or rotating a picture frame on a wall. These are all real-world examples of transformations applied in a digital environment. Transformations are fundamental building blocks in computer graphics, enabling us to create dynamic and interactive experiences. They provide the means to animate objects, control camera views, and render complex scenes with depth and perspective. Without transformations, computer-generated images would be static and lifeless, lacking the dynamism that makes them so captivating. There are three primary types of transformations in computer graphics: translation, rotation, and scaling. Each of these transformations affects objects in a distinct way, and they can be combined to achieve more complex results. Translation refers to the movement of an object from one point to another in space. It's like sliding a piece of paper across a table without changing its orientation or size. Rotation, as the name suggests, involves spinning an object around a fixed point, much like turning a steering wheel. Scaling, on the other hand, deals with resizing an object, either making it larger or smaller. Imagine enlarging a photograph or shrinking a document on your computer screen. These actions represent scaling. To better understand how these transformations work, let's consider some practical examples. In a video game, moving a character across the screen is achieved through translation. Rotating the character to face a different direction involves rotation transformations. And changing the size of the character, perhaps to indicate growth or power-ups, relies on scaling. The applications of transformations extend far beyond video games. In computer-aided design, CAD software, architects and engineers use transformations to manipulate three-dimensional models of buildings and structures, enabling them to visualize and refine their designs. Medical imaging relies on transformations to create detailed representations of internal organs and bones from scan data. And in the film industry, transformations are indispensable for creating special effects and animating lifelike characters. Transformations are the unsung heroes of computer graphics, working tirelessly behind the scenes to bring digital worlds to life. They provide the tools to manipulate objects in space, creating the illusion of movement, depth, and perspective. Without transformations, computer graphics would be reduced to static images devoid of the dynamism and interactivity that make them so compelling. From animating characters in films to designing buildings in CAD software, transformations play a crucial role in countless applications. As technology continues to advance, the importance of transformations in computer graphics will only continue to grow, shaping the future of how we interact with and experience the digital realm.